on the car. So if we were, for example, going to do the new aileron long wheelbase spiker, there'd be multiple ways that we could capture that car. And depending on the access we get, so if it was a classic car, there's only one of them in the world, and it's in, say, Ralph Lauren's garage. Those are the types of cars that we have to be very careful. And so we'll usually go on location. We go all over the world to capture cars. We take thousands of photographs. We videotape as we turn the car on. We get the audio. Now, if it's a car we get full access to, we'll put it on a dyno. We will capture the audio of it. And often we'll also laser scan the car. So that means putting this fine line on the car and then using a laser to go across and scan into 3D modeling software. Now, whether we actually laser scanned it in or got CAD from the manufacturer or took the photos ourselves, it's very quick, the next step, to translate that into a high-resolution mesh. We use Max, and we have artists all around the world working in this program, and we then bring those in and quality assure them, do quality testing, really make sure that it looks right. We set up the textures and the shaders, everything to do with, you asked for a technical answer, so I'm giving you a technical answer. Set up the Alcantara and the suede and the wood, and really make all the textures look just right. And then we end up modeling the physics as well, and that's done through a very complex simulation system we have. The physics simulation itself, there's two major steps. So the first thing, we hire an entire team of subject matter experts, and they do all of our research. So even though the manufacturers will often send us data, we don't use their data. It's not in our best interest because they're not necessarily as technical as we need it to be. So we research the cars, and a lot of times it's not researching the actual car. We research who provided the parts that made the car. So the third party that provided the suspension, for example. Often the suspension, even in a big manufacturer, is not actually made by the manufacturer themselves. So we research every component that goes into the car, and that allows us to get suspension geometry, even on a car that nobody's driven yet, because we know it was manufactured by this group, and that group tells us where the multi-links are. So that's the first stage of simulation. We have a server that runs all the cars through a simulation and generates 9,000 data points on every single car based on that simulation. Then it goes into the real-time simulation. So those 9,000 data points are used in our real-time simulation to simulate how it drives dynamically. What it comes down to is we do our own research, and so our research does not always mesh with what the manufacturer is saying. We don't have a disagreement, we just put in what we researched because we believe our research is accurate. I mean, it's the same thing if you read a motoring magazine. There may be one magazine that says the car 0 to 60 is 4.2, and some other motoring magazine says that 0 to 60 is 4.5, and the manufacturer may say that 0 to 60 is 4.4. They're not all the same. So by researching the base physics, we're able to get a very, very accurate simulation. We have two types of experts. We have general experts, and the general experts are very good at researching, and they call up different companies and different manufacturers to piece all of the data together. We also have subject matter experts for specific components when we're upgrading the simulation itself. So we have hired consultants from StopTech, braking. We have worked with guys that worked on suspension models from actual suspension companies. And we bring them in to help us make the model, the overall model, better. So that's not on a specific car, that's across the game. Right, so the way that works is we've always stressed tires because the math of doing a suspension geometry is actually fairly straightforward. And we do a lot of complex math, such as chassis stiffness and chassis flex. But while it's complex, it is straightforward to understand. Tire simulation is an ever-evolving science. We're always learning more as an industry. The games industry, the racing industry, the car industry is learning more about tires. So in Forza 3, we had a data model made up from data from Pirelli and from Goodyear, the SAE, from lots of places. And then we took that data and blended it together to make our tire model. And we felt it was extremely accurate. But the only way we felt we could get even more accurate is to throw all of it away, get ourselves out of it entirely. So we changed our model so we could accept data straight from a manufacturer. And we went to Pirelli and asked them to do custom tests across a huge range of tires and variables. Different widths, heights, sidewall stiffnesses, gas pressures, heats, camber angles. They tested for a long time, and then they sent us reams and reams of data. And we input that directly into the game. Now that is the same way that Ferrari builds their F1 simulator and McLaren builds their F1 simulator. They ask for custom tests from the manufacturer of the tires, and they input that in their simulation. That was the only way we felt we could have the most cutting-edge tire simulation available on any platform, any PC, anything, was to actually get out of the way and let the data do the talking.